Yeah, so thank you all for staying so long till the end. I know it's been a long night. If your brains aren't completely full of stuff, maybe you'll pick up one or two things I talk about. Yeah, my name's Tom. I do study here in Dumfries, working on sustainable materials. Really grateful for the opportunity to talk to you about this. It's nice to have a captive audience that I can rant at with no one being able to leave. So, yeah, anyway, let's start. So we do need to face the fact that as a society, we are completely addicted to plastic. We've gone from that person who liked a wee drink in the evening to having whiskey in their coffee in the morning, and we need an intervention. It's got to stop. But why do we love plastic so much? I mean, the problem is we're completely surrounded by it. It's in our cars, our phones, we wear it at the food, it's in our house. We've talked a lot about packaging. It's probably the main culprit. I won't go into it now because I think most of what we've had so far has been on this. But yeah, when you think of something that lasts 30 years in your house, like a plug socket, you can justify that with something that's only job is to get it from the factory to your plate. That's not so great. But I said, why do we love it so much? Well, actually, plastic is an incredible thing. It's so useful. It's lightweight, it's cheap, it's tough, it's flexible. We can form it into any shape you can imagine. It's resilient, and it's resistant to things like waterproof, weather, and it's this resilience that is the main problem. It's why it lasts so long in the environment. It can last for hundreds of years, and that is a big part of the problem. But we'll talk about some fun graphs now. Everyone loves a graph, or maybe it's just me, I don't know, but some statistics to warm you up. We've got here, this is from Plastics Europe. This is a huge, big organization. They publish papers every year on this. Top, we've got statistics on the world. Bottom, we've got Europe. We'll ignore the graphs for now, but you've got these rings here, the left and the right. We've got the gray stuff in the ring. That is the total amount of fossil-based plastic that's produced every year in the world. And it's up there. I can't read this and this. It's about 90%, which is really high. Europe, we're a bit better. It's about 80%. And out of this, what's recycled? You've got in Europe about 9% recycled in Europe. And that's recycled by the consumer. That's us, you and me. And then in Europe, we're a bit better. We're about 13%. And only less than 1% of this comes from bio-based, that's renewable sources. So, things really do have to change. But before I get into alternative solutions, I want to talk to you a little bit about recycling. Now, I am all for recycling. I recycle everything religiously. I'm definitely not here to tell you not to recycle, but it would be remiss of me to not point out some of the limitations of recycling. Now, when we talk about a plastic, what we think of as a plastic, it's usually actually a mixture of one or two base resins all mixed together. They're blended together. We throw in a load of additives, which can be plasticizers, which make it more flexible, more easily formed, things to make it process more easily in the factory, things to impart additional resistances such as weatherproofing, fire retardants, etc. And these mixtures of everything, they quite often closely guarded secrets by the suppliers. They don't want us to know what's in there. And on top of that, I think we mentioned about composites, often multiple different types of plastic or other substances are glued together. An example of this is the drinks cartons. You've got paper with in between two layers of plastics. So this makes recycling really challenging because, first of all, you don't know what's in it. Second of all, they're all different. Third of all, separating them is a logistical nightmare. So keep on recycling. Just be aware that recycling on its own is not going to be enough. We can't solve this problem just by trying to recycle 100% of what we have. Now, let's look at this problem itself. Turns out it's not just one problem. There are two challenges that plastic uses posed to us. First one being climate change. Now, we know that fossil fuel usage contributes to climate change. There's actually been a 1% rise in global temperatures within the last 100 years. The chemicals industry counts for about 15% of all fossil fuel usage, plastics being a major part of this. And if this trend continues, every time the report comes out, the predicted rise gets higher and higher. You're looking at least 25% of all species on the planet are at risk of extinction. The second one is this plastics pollution, which I won't go into this because I think you've been overwhelmed by this now, but just be aware that, because of plastics' highly resistant nature to degradation, it ends up accumulating in landfills. Usually it ends up in the natural environment, which is mostly the sea. So there's a lot of talk about sustainable alternatives. So what is sustainability? Well, it was first coined by the United Nations in 1987, and it is defined as the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. In terms of materials, more specifically, it is the degree to which production or usage avoids damaging the environment or depleting finite natural resources. So to prevent it accumulating within the environment, it needs to decompose naturally within a short amount of time. Nick was talking about a bottle can be in Ireland in a couple of days. Can we degrade? Probably can't degrade that fast, but we definitely don't want it circling, doing 3 laps of the ocean before it ends up back in our beach. We also want it to degrade without releasing harmful chemicals. A lot of these additives I said are added in. They can leach out, form persistent organic pollutants, which can remain in the environment for a long time, causing a lot of damage. To avoid depleting natural resources and contributing to climate change, we want it to be produced by a renewable source. Really, this is limited to plants or animals, and that is what we call bio-based materials. Here's some examples of some sustainable plastics. You've got the circle on the left in blue is bio-based materials, circle on the right in yellow, biodegradable materials. What we're really interested is where they meet in the middle. You probably won't recognize many of those names because we don't use them. They're not commodity plastics. But you might recognize some of these naturally occurring materials in the green, such as starch, collagen, latex. So that's what we'll be talking about. But before I do, I want to talk about this little circle of 3 things in the top left there called drop-ins. So one of the big problems with shifting towards sustainable solutions is it's going to have a major impact on our life. The way we live, and we're so dependent on plastic, our way of living is probably going to become worse. Our standard of life will decrease, whether that's because it's more expensive or we can't store things for as long. But what if there was a way of having enjoying all the benefits of plastics we currently live in, but without causing the harm to the planet that they currently do? Well, this group of materials may be the solution. They're called drop-ins. Basically, you got your standard commodity plastics, such as polythene, polypropylene, polyurethane, but rather than being made from oil we dig out of the ground, they're made from renewable sources, such as plants. Usually bacteria will make them or some other chemical process, but we can synthesize these from renewable sources. This is great. Carbon neutral. We already have the infrastructure here to support it. All our factories and products rely on this. All you need to do is slot in at the bottom, change your supplier to someone who makes these renewable sources. Really, everything stays the same. It's what we call a business as usual approach. We can even, you talked about burning plastic waste. Now, fortunately, burning the plastic waste does contribute towards greenhouse gas emissions, but with these, it's actually carbon neutral. You could do that without this problem. The downside is it is very expensive, several orders of magnitude more expensive than the way we currently produce plastics. And the technology does not yet exist to meet the capacity of 7 billion people. So let's look at something a bit cheaper. There are plastic-like materials that already exist within nature. And the advantage of this is that nature's doing most of the work for us. We still might not have the capacity to produce these, but we do have 10,000 years of experience of farming, so I'm sure we could catch up if we need to. One major advantage of this is that production could be localized. Not many of us have oil derricks in our back garden, but we do have, we're surrounded by fields that could grow crops, so we can produce it locally rather than importing oil into us. And it turns out as well that we don't need to grow crops for this. When we grow crops, the valuable bits can be used for other stuff, and we can take what's left and convert that into these materials. These are called waste streams, and they are a vital part of any circular economy. So this brings us nicely onto my particular research. This is cellulose. Cellulose is a vital part of all plant cell walls. With a bit of mechanical processing, you get down to these three components, which is cellulose, hemicellulose, and lignin. Now, unfortunately, from this part on, it's quite difficult to purify them. You need chemicals, bacterials, more mechanical processing. But if you can separate them, you get ideal substrates for biofuels, polymers, biochemicals, etc. However, what does Dumfries have a lot of? And I don't mean rain. We got a lot of cows, and it turns out that when cows eat this plant matter, they do a lot of this work for us. All we need to do is get what comes out the other end, and most of the job is done for us, in theory. This is the next slide. We are taking the humble cow pat and trying to make the next generation of green materials, or as I like to call them, brown materials. Sorry, I shouldn't say that. My supervisor would kill me if he was here. He is. During lockdown, I started looking at the research that is in this kind of field, making, no pun intended, making materials out of manure. Whilst there weren't that many studies, the amount of different areas it was applied to was remarkable, from building materials to car brake pads, packaging, electronics, power sources, rather disturbingly, even medical devices. Not sure how I'd feel about that, but it is there. Now, this is probably the most interesting thing we're working at now. This is nanocellulose, and this is the plant fibers, the cellulose, that have been ground down to such a small size that they're 100 nanometers in width. And just for perspective, there's 1 million nanometers in just 1 millimeter. So you can't see these with the naked eye. And when they get down to these scales, you get some remarkable emergent properties. Weight for weight, they are several times stronger than stainless steel. They're either flexible or stiff, depending on how you pack them. They're transparent, making them very attractive for electronics like screens and things. And because they're completely natural, they're non-toxic, and they are tolerated very well by the body. So that makes them extremely good for medical devices and implants and things. Yeah, so just to summarize what I've been through, if anyone's still awake. We talked about the environment. You'd seen that there's two problems, plastic waste and climate change, that need to be addressed, and how recycling is not enough to meet these needs. We've looked at some sustainable alternatives. They need to be biodegradable, they need to be bio-based. We've seen 2 examples, drop-ins, which are great in theory, just a long way off, and natural polymers, which are much more achievable. And we've looked at sort of the future technologies, the stuff that we're researching now, which is taking waste streams and making very high-tech materials from these, such as nanocellulose. So, thank you all for listening. If there is time, I take your questions now, or you can email me on this address below if you'd rather. Hi.
I think one of the slides you had alginated, which is seaweed, isn't it? There's a company called Notpla that is developing, they got an award from the Prince of Wales recently, developing not plastic single-use sachets for condiments, water capsules that you can just eat. I don't know if you've been aware of that.
I have not aware of that, but seaweed is one of the things we are looking at. It's something that we get a lot of in Scotland, so there's a lot of interest in this. But yeah, you're right, alginate. Okay, that's really interesting. Thank you.
Is there any idea of time frame?
For my work or for plastic in general?
No, about your work. You've given us an idea of what's happening. No perception.
Yeah, I mean, we are early stages here. We can kind of make nanocellulose, but in very, very small, very difficult. So the problem is you need to scale it up. And one of the problems with nanocellulose is that it's very expensive to produce. You can only make small amounts, which is why we're looking at manure, because it's cheap, and as I said, half the work's already done for you. Myself personally, I've only got a year and a half left to finish it, but there are a lot of labs looking at it around the world, but as of yet, I don't think there are any commercial producers of it, especially not from cow manure. I think we're the only people.
I don't know if you can answer this or not, but with water bottles and that, you hear that you can't use them so many times, but because of whatever's inside them. But is there a shelf life for the use of the reuse of a bottle? How many times you can use it?
There was a problem where certain chemicals were leached out, these called BPAs. I believe that this doesn't happen with most of them anymore. I think there was a sort of directive to get rid of that. I could be wrong. Certainly with plastic usage, you see a plastic bottle washed up on the beach. It's nothing like this plastic. It's lost all its flexibility. It's because all the plasticizers and things have come out. There's been a lot of, the molecules inside have been changed. They've been cross-linked together, which makes it much harder. I would imagine the lifespan of a bottle, however, is probably longer than the time you will hold on to it before losing it. Probably last years. I would definitely recommend not using plastic bottles, getting your own bottle, which you can use indefinitely. But I don't know if that answered your question, sorry.
No,
If you're talking about recycling plastic bottles, there is a problem when you recycle them that they lose. Aside from the problem I talked about of the additives, it does lose a lot of its properties when you chop it up, because they do it quite cheaply. They chop it up, they put it back together again. It's like a jigsaw. It's not going to be as strong as a whole piece.
Yeah, I think you can only use a plastic bottle about 3 or 4 times, like recycle it 3 or 4 times.
Yeah. One of the things that annoys me with Coca-Cola bottles is that it says 100% recyclable. None of it is recycled. It's just you can recycle it. It's like it puts the onus on you. It's like, oh, it's green as long as you do the work for us, and that's annoyed me.
Interested in your project with regards to farmyard manure. I followed the work on seaweed. And the advantage of seaweed is it comes from the sea and is readily transported to factories adjacent to the sea. Now, as I cycle up and down the Old Military Road meeting slurry tankers every day, I really don't want to see how you're going to transport all this to some manufacturing point. Or are we going to have, instead of cabling along the side of the road, you know, lots of pipeline stuff?
Piping seaweed. So being told people asking about seaweed, I think I might be in the wrong field. Yeah, and this is one of the transition may involve localization of production. Rather than having one big factory in Eastern Europe, maybe we could have lots of small ones, you know, close to the source. Transport will always be a problem, but in terms of the carbon footprint, it's the shipping raw materials from one side of the globe and the products back. That's one of the big contributors towards greenhouse gases, and if we can circumvent that by having stuff locally, I think that's going to be a big step forward towards a greener economy.
One more question.
I think that's the inherent sort of observation around solutions is because we can doesn't necessarily mean we should, you know, and the kind of the arguments for is the balance between the mechanisms of government that, you know, how we use land, how we integrate land use and ocean use. If we put all our eggs in one proverbial basket, then macroalgae are going to have a knock-on impact on food chains of our oceans, and we won't even know it's happening because we don't study our oceans closely enough to see that we're changing that now. And so, as part of your research, is there that ethical question around are we resolving a problem without changing behaviour? And I suppose it comes back to the single use. You know, if we can solve the problem, are we how do we deal with the front end parts of cow production? You know, to make sure that's sustainable, and is it part of a big kind of, you know, do you have to tackle within your research the kind of ethics of the sort of solution, bio-solution? Is that something that has to be tackled once we kind of control it, once we understand it?
That's a very good question, yeah. I personally haven't looked at that. I don't think I don't think we're very close to a point where it would hit that sort of commercial success. I'd like to think it does in the future. But I think this all comes back to Charles was talking about how by fixing one problem, you can actually introduce several others, and there's got to be some responsibility in making sure that that doesn't happen. In terms of cows, we're not actually growing we're not making cows to produce this. The cows are there to produce milk. We're just taking this other thing that the cows produce in huge quantities and trying to make something valuable out of this. But if there were no cows, if we suddenly decided, because cows are quite bad for the environment, if they decided that there were no cows, then this would not be a green solution because we'd have to have cows specifically for this.
Okay, thank you very much, Tom.